Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hello, everybody. We're here for the podcast for securing the vehicle computer to enable software-defined vehicle. My name is Colin Mundell. I'm a security account manager here at ETAS, and I am joined by one of my colleagues, a security expert, Omar Al-Shabibi. Omar, can you give a little background?
Yeah, thank you for having me, Colin. Greetings everyone. It's Omar Al Shabibi. I'm a lead product manager at ETAS, responsible for cybersecurity solution for system on chip, automotive system on chip.
Awesome. So, the SDV, or software-defined vehicle, is a global automotive industry trend that brings tremendous value to the industry. Could you shed some light on the benefits of the software-defined vehicle to the OEMs?
Yeah, absolutely. So before we deep dive into some of the benefits of SDV, I wanted to just give a high level definition of SDV. I'm gonna give like a 200,000 feet view, high level definition in a simple way.
Sounds good.
As SDV, it's like imagine it's a computer on wheels, or it's like a cell phone on wheels.
Okay.
Meaning now you've advanced the vehicle. The vehicle is no longer mechanical or electronic components only, but it does have software functionality and a brain that acts and has ability to enable the driver to interface with the vehicle as if it's the vehicle, the phone of the driver, right? So that kind of try to simplify the way, meaning is different software applications could run on the vehicle. You could run different social media app on the app on the vehicle, and you have the ability to interface in a way that enhances customer experience. This is one of the great benefits, right? And increasing automation within the process in terms of driving, in terms of performance, in terms of interaction, right? So that is the automation, enhancing customer experience. Also, the SDVs, it's creating a new ecosystem for the OEMs and the entire automotive industry, including, of course, the end consumer of the vehicles. That business model is enabling OEMs to add additional way of making revenue. It's a different mindset of approaching the vehicle, right? The vehicle leaves the just as another simple definition of it. The vehicle leaves the dealership, and
Hmm.
you can add on top of the vehicle. The vehicle is no longer like in the past. You buy a vehicle and that's it. The connection between the OEM and the vehicle and the owner is gone, or the vehicle is the same vehicle. No, you might buy a vehicle now, and the same vehicle that you bought now, it's different a year from now. Why? Because you added additional functionality to it. You enhanced things on the vehicle because it's connected to the backend of the OEM. It's connected to the private or public cloud. Has the ability to download software functionality and improve performance and or customers experience. So that is the different way of thinking of how the vehicle will look like. In addition, that vehicle with this software defined ability establishes a new feedback loop. As I said before, the vehicle leaves the lot, and yes, you come to the dealership to do exchanges, fixes, maintenance, oil change, yada yada yada. That's awesome. But now, even without going to the dealership, the vehicle still has the ability to upload information, provide feedback loop to the OEMs to improve the design and the development of the new set of vehicles or the new set of new model, new make and brand and stuff like that, right? So this is important. Additionally, it enables preventative maintenance, right? So that is the thing that you wanted to do and saves cost for the driver, saves cost for the OEM and stuff like that. So that entire ecosystem, it's actually adding tremendous value and a different experience and different way of interfacing with your vehicle.
That sounds great. So it sounds like the EE architecture is transforming from a decentralized ECUs to more centralized ECUs. Is this one of the key enablers for software-defined vehicle? And if so, could you please elaborate more on that?
Yeah, absolutely. So without having an evolution on the current E architecture, it's hard to realize software-defined vehicle. You do require to have an evolution from the current, what I call the distributed E architecture, into more domain or centralized E architecture, and then that domain centralized E architecture actually moving towards connectivity and continuous connectivity to the cloud, private cloud, public cloud, depends on your implementation, depends on the OEM. So that evolution on its own, it's one of the key pillars to get the SDV moving towards realization. And one of the foundational, I would say, and a cornerstone of the E architecture is having a vehicle computer ECU in it. Vehicle computer, it's actually evolved in a way now we can define it simply as an intelligent computer system that collects and processes complex and high bandwidth data from different ECUs and sensors within the vehicle, such as ADAS, infotainment, navigation, and different powertrain applications. So that the brain of the vehicle is a vehicle computer where it's actually optimizes vehicle performance and operation and connects with different sensors such as camera sensors, radar sensor, and lidar sensor. All these together combined are important and parameters and foundational aspects to enable software-defined vehicle.
Sounds great. So I guess we'll move on to securing this centralized ECU. Can you tell us a little bit more on how important the security is when it comes to the new EE architecture of the software-defined vehicle, and then also elaborate more on the relevance of security when it comes to these typical vehicle computers?
Yeah, this is one of the greatest questions, to be quite honest, because it's without security, it's hard to realize software-defined vehicle. With the all the amount of software layers are being developed and deployed in a vehicle on these vehicle computers and other powerful ECUs, and the connectivity of the vehicle, right, and the constant update that you need, right. So that all these different parameters combined together, they make security much more critical, and I would even call it like it's a prerequisite. Security is a prerequisite to enable that functionality in the car.
Okay.
It's a paramount when it comes into SDV. It's an integral part of the SDV ecosystem to ensure there's integrity, authenticity, and trust in your system, and prevents any sort of malicious attack and unwanted behavior of your entire ecosystem. I can give like a quick example here. Imagine if you're building a high rise, you try to construct a high rise building, right? What would you start with at the beginning, Colin?
I would start with the foundation.
You bet. So foundation is something that needs to be designed, developed well, and laid out, and you take the rest of the structure on top of the foundation. So if you want to get this high-rise building to be constructed in a way that it's actually can could withstand the different like weather conditions and the load that you can add to it and stuff like that, you need to have this considered very well. So something similar to the automotive industry and the ecosystem that you have here. Security is a foundational thing. It's part of the design. You need to consider that one in order to prevent any sort of rework and reduce cost over time, and not to have think of security after the fact and then you have to go back and redesign things, and which could be costly and might affect your time to market. So that's the thing that we're trying to here push for, and also our customers understand as well. As a matter of fact, we are not only talking to the market about security, but the market now is talking back to us because they appreciate, they understand the value, and they see, that's it's how security needs to be considered right from the beginning. And also, it's not a one-time event. It's like think about it as like a life cycle thing. It's a
Hmm.
throughout the entire ecosystem. It's a throughout the journey of the product development until you decommission your product.
After learning about the importance of security while enabling the software-defined vehicle, what could be the impact of not considering security for the vehicle computer ECU?
Yeah, and this is also a good question and revealing question. So, of course, the impact, it depends on the situation, depends on the vulnerability, depends on the implementation. It's a case by case basis. However, in general, without having cybersecurity in your process, in your development, in your environment, right, it increases the risk, increases the threat. And if it happens to be, for example, if you ended up with a security breach and you have your vehicle that is powerful with software, enabled with the functionality that increases automation and having that, the benefits that we talked about, the SDV, and connected with your entire backend ecosystem, connected to drivers' phones, you know what I mean, has a personal data on it sometimes, right? If any breach happens, that could be the impact could be high, could be really severe, I would say. In some instances, it might put you at legal impact. It could have revenue loss and definitely will have reputation loss. So no one wants this to happen, right?
Mhm. Yep.
So that is something that we see the industry understand this very well, and the OEMs are actually equipping themselves to have cybersecurity solution embedded into their processes, embedded into their development. I would also go and I would say security is a mindset, right? So you need to have this in your infrastructure, you need to have this in your product development to ensure that your end-to-end process is governed by security, and of course you continuously monitor and optimize as you move forward. But definitely it is, could have severe implications, and the market does understand this and they're acting on it.
I've heard this term, computer on wheels or cell phone on wheels. Is the security for the software-defined vehicle, are we attempting to try to get the security to where cell phones are today? Because I know the automotive industry is a little lack or a little behind in the security, behind security for cell phones and enterprise. Are we moving in the right direction to get cars to be the same level of security that our personal cell phones and laptops are?
Yeah, I mean, definitely there is a big learning happening from the enterprise and other software applications and industries, as well as the mobile industry itself. As we said at the beginning, now you're interfacing with your vehicle as if it's your phone, right?
Hmm.
There's a different experience now. Like, you have all the different sensors in the car. You have the radar, you have the lidar, you have the camera sensors, all the ADAS functionality within your car, right? That brings that safety and convenience when you drive, right? Now it becomes an expectation of consumer. So with that functionality in place, with that evolution that happening on architecture, security has and mindset of the tier twos, tier ones, and OEMs has evolved in a way that security is a must-have, and that's something that we it has to be considered. Meaning, we can learn from the mobile industry and how they have achieved security on the entire ecosystem, right? So
Hmm.
downloading updates on your phone on a weekly basis, or like, twice a month, right? It's happening in a secure way.
Hmm.
You've achieved secure OTA on, over the air update for your phone, right? You're storing your biometric information on your phone, right? So that is stored in a secure enclave within the SOC of the cell phone, right? And your passwords, your banking information, right? Nowadays, most of the population using their phones to perform banking transactions, right? So that's a critical transaction. It's a personal transaction, right? So that's secured on its own. So meaning now that experience and also the knowledge that the automotive industry has developed for the last few years, it's all coming together to build that cybersecurity ecosystem to enable software defined vehicle. I can give you a simple example, like the cornerstone or the foundation of the new architecture is the vehicle computer, as we said. That vehicle computer on its own, it does have, it does require, I would say, a powerful system on chip. Why? Because it needs to compute a large set of data and has to deal with different sensors and different ECUs, right? So that means, you need to have a stronger and more capable platform. These system on chips have dedicated security hardware core, and that on its own, it's important. And it is getting into a point where I would say you can protect and secure your crown jewels, the key cryptographic material and the secrets and the confidential information within that dedicated secure core within the same chip, right? To ensure there's trust, authenticity, and integrity for your communication, and for your update, and for your when you boot the ECU and stuff like that. That is on its own, that security module, we call it, depends from one hardware architecture to the other, could change the name, but the industry name is pretty standard, like using the HSM, hardware security module.
Hmm.
And that on its own is a critical component to ensure all the security elements that I talked about is in check.
Yeah, and that sounds like a complex problem that the software-defined vehicle is running into. Are there any ETOS solutions that could help secure the onboard vehicle computer that are in development today or out today?
Yeah, absolutely. So, but before we deep dive into what the possible solution could look like, we can let's just take a segue and talk about challenges, right? So what are
Yeah.
the challenges here? Like, we talked about the SDV in a nutshell. We said it's a computer on wheels and has all the capabilities that can be unleashed to the consumers, right? And we talked about the evolution of the architecture that enables the SDV. And then we said one of the most important and critical and foundational point of the architecture is a vehicle computer. This is gonna, I'm trying to drill down from the macro level, big picture, all the way into the to the details,
Uh-huh.
right? And then within the vehicle computer, you have the like the vehicle computer ECU. You need to have a powerful computing platform, and this is the system on chip. It's a microprocessor based system on chip. In order to enable the all the different software functionality you have, if you're on POSIX, you're on classic and adaptive AUTOSAR, you run different applications on top, the hypervisor that orchestrates all the functionality and add the separation and isolation. You need to have a microprocessor, excuse me, based system on chip, and this is important. So with that architecture of system on chip, it's actually introduces another challenge. That architecture is so diverse and heterogeneous and has some shared resources like the external flash, because there is no longer internal flash inside the SoC. It's
Hmm.
always external because of the resources and the design of the new SoCs, right? That on its own introduces another challenge to how secure and implement security use cases on these SoCs, which is in return and ensure that security use case is implemented on a vehicle computer and then to the rest of the ECUs. That is the nucleus, I would say, of the vehicle computer.
Uh-huh.
Meaning now the implementation is now require a different way of thinking. Security use cases have not changed. You still need to secure to boot the ECU securely. You need to communicate securely. You need to update securely. You need to access the ECU securely and stuff like that. You need to do diagnostics securely. This is like a very much intact use cases. The implementation now is getting into different ways and different way of thinking and does require a different mindset. So with that challenges of the different hardware architecture and the complexity of different software components that and software layers that need to be added to enable the SDV functionality, we have introduced a solution to fulfill these challenges and also fulfilling the OEM's automotive security use cases. So with
Awesome.
that, we established Cyber SoC, which stands for Cybersecurity for System on Chip, and that solution is basically addressing the cryptographic functionality of the system on chip, leveraging the dedicated security hardware module, and also running software components, security software components on other CPUs within the same SoC, and unleash the potential of SoC that it's with the high performance and more capability, while maintaining performance, trust, integrity, and authenticity in place. So Cycler SoC is available and it's running on different platforms, and we are working with our clients and customers by listening to them continuously and adapt and modify to fulfill additional needs.
Oh, thanks so much, Omar. I know you mentioned trust. Can you give a little background on no trust for listeners that may not know what that is?
Yeah, absolutely. So zero trust concept is one of the key advantages that Cycle SOC can offer, and how we designed and developed our solution, right, to fulfill the automotive use cases with that zero trust concept in mind. Meaning is zero trust concept, if we go and use the specific and exact meaning of it, is you don't trust anyone, you don't trust anything. And here's the thing, these SOCs, as we talked about them, the SOC itself has like multiple computing islands within the same chip, within the same die, and you could run different software applications and operating systems within that SOC. And each computing island is responsible for certain use cases, certain applications, right? Like some, rich execution environment and real-time safe island environment and stuff like that, right? These different CPUs within the same chip, you know, you don't need to because they run different software layers, so the attack surface is has increased. There's a possibility, and instead of, for example, I'm going to make a very simple example here. You have a platform that runs 100,000 line of codes versus a platform that runs 1 million lines of codes, right? So of course, the more you add functionality, the more you add software, you more expose your environment, and the attack surface possibility increases here and likelihood increases. So meaning is, you can't just trust every computing island in your microprocessor based system on chip, right? So meaning, the dedicated separated core is the trusted environment in that ecosystem, where you can save your crown jewels. When I talk about crown jewels, I talk about the secrets, the cryptographic material, the material that you use to encrypt, decrypt, sign, verify contents, messages, software update, and stuff like that. That is what is actually being maintained and run by the dedicated security core, while you have the ability to run some cryptographic operations outside that dedicated core on the other CPU components of the SoC. So that design fixes the problem of how can we trust and what can be trusted, what can't be trusted, and how we orchestrate between sharing keys, not sharing keys, and how we fulfilling that the automotive security use cases such as secure communication, secure debugging, secure access, without compromising security, but also keeping performance in place. We don't want to use a system where security is in check and then affecting performance, or vice versa, right? So that is the design, the implementation that we've crafted and we've implemented, and it's running on different platforms. That is that we have the zero trust concept, and this is one of our proposition, and it's actually being received well and by our customers.
Awesome. Thank you so much, Omar. Thank you for
Absolutely.
so much for joining us, and everybody have a great rest of your day. Omar, do you have any final words?
No, I say thank you for having me, and any questions, concerns, reach out to ETAS solution sales teams, and we'll be more than happy to help you.
Awesome. Thank you so much. Have a great day, everybody.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.